Okay, so in this video we're going to look at how to improve on problem 14. This was the longest Collatz sequence, so we're going to look at how to add our known Collatz values to like a lookup table, or a dictionary in our case, and then retrieve those and help save us having to do some numbers multiple times. So for example, like if we Collatz 2, we find out the answer of that. Then when we Collatz 4, we know 4 goes to 2, so we would just say the length of 4 is whatever the length of 2 is, plus 1, because it only takes one step to get from 4 to 2. Hopefully that makes sense. If not, don't worry, we'll be going over it in a little bit more detail. So what we're going to do first here is we're just going to comment out this code, because I want to go through what dictionaries are. We've not actually seen them before or used them before yet. So we're going to have dict of known Collatz. This is going to be actually, not yet. We're going to have dict of ingredients. Oh, I can't spell. Now, to define a dictionary, it's similar to a list. How with a list you do square brackets. With a dictionary you just do curly brackets. Now, if we print the dict of ingredients and we run this, you see we just get an empty dictionary down here. That's what these curly brackets mean. Now we can put stuff in here, so we could say milk, and we could say we'd have milk, and we could say that as a value of, say, 1. Now if we print this, you see we get milk and we get 1. Now one of the useful things of dictionaries is we could say print dict of ingredients. Then what you do is you call, similar to a list, how you call from square brackets and you call like an index. Instead of doing that, what you do is you call the actual item you want. So we're going to call for milk, milk. So if we run this, you see we get milk here. We still print the dictionary. Now when we've called dict of ingredients milk, we've actually got 1. It's given us the corresponding value to it. So this number 1. Now this is generally how you're going to be using dictionaries. You're going to have what's called a key. So the key for this is milk, and then you're going to have a value. So each key will have a corresponding value, and generally you're going to look up your key and retrieve your value. It is possible to do it in reverse, but not much use for doing that I've found. So yeah, that's the first thing we should probably know. Now a couple of other things, we're going to have like how to print all keys. So you see we get like a list here of all the keys. So if I add a few more things to this, so we're going to have flour. Oops, I'm getting these quotation marks. So flour, we're going to have 7, and we'll have eggs, and we'll say that is 3. Now if we run this, you see we get a list of all our keys by calling this dict of ingredients.keys method. Now we could do the same thing for values, and this should give us a list of all the numbers, so you see it does. So now what we can do with this is we can say we could have this dictionary be, instead of it holding milk and flour and eggs, it could just hold numbers corresponding to other numbers. So for example, when we Collatz 2, we could say 2 has a length of 2, which it does. I'm just going to get rid of this one because this one was specific to the last example. Now if we say 2 has a length of 2, when we Collatz 4, we could look up and say, have we already done 2? So is 2 part of our values, part of our keys, sorry. If 2 is part of our keys in our dictionary, we can say, right, we know we've done it. So now check the value associated with that key, which in this case happens to be the same number, but it won't always be. And then that's the length that we need to take. So hopefully that helps. If you don't understand all these, don't worry, we're going to be going over them a little bit more when we actually get to coding it in. I haven't used dictionaries in a long time, so there might be a few mistakes here, but we'll get it working, so bear with it. So let's set ourselves a target. So I'm going to run the old code. This is pretty much this code, just the old file. I'm going to run that. Our target is to beat that time. We're going to see if this actually gives us an improvement. So there's two things I'd like to do. Step one is when we collatz x, what we can do when we find out the answer to x. So if I go down here and I say if I say on this line print x and current chain, and say I only collatz up to 10 when that's finished running, so you'll see here this is going to print out each number up to 10, and it's going to print out the length of that chain. Now what we could do on say this line is say append to that dictionary or add to that dictionary. Oh, that's one more thing I should probably go through, how to add to a dictionary. That would be really helpful. So rather than so if we have dict of ingredients, and we have milk, that was 1, and we have eggs, and that was 3. If you want to then add flour to this, what you can do is you can say dict of ingredients, and then you don't do it like you do a list. You don't do the append method. That's a list specific method. Now instead, what you do is you try to call it. So you say like basically dict of ingredients. Now we're going to add flour, so we're going to say flour, and then you say equal to, and then whatever it's equal to. So 7. Now if we print dict of ingredients, I'm going to print it up here just so you can see it didn't actually have that before. You can see here, by the way, our thing took 69 seconds, so that's our target to beat. Now you see here we've got milk, eggs, and then we've added flour. Sorry. Now you see it doesn't append at the end; it's just in there at the beginning. That shouldn't matter because you're not actually going to be looking in the dictionary by index. You're going to be looking by key. You're going to call certain keys. So yeah, hopefully that helps. So back to what I was saying. If I now run this, so you see we get 1, that has a length of 1, we get 2, that has a length of 2, 3 has a length of 8, 4 has a length of 3. Now what we could be doing on this line right here, line 20, we could add to our dictionary whatever x is and whatever its chain is as the key and the value. So the key would be this number and the value would be this number. So we could do that, and in fact I will do that first, but what I'd like to add after that is I'd like to add all the values in the chain. So if you see the collatz length, the collatz of 3, so if we just go up to 3 here, that's not right, go up to 4 so it includes 3. So if we do this and then we say print current number right there, you see for 3 we get where's it at? So for 3 we get 10, we get 5, we get 16, we get 8, we get 4, we get 2, we get 1, and then it says 3 has a length of 8. So what I'd like to do here is I'd like to be able to add this 10 to our dictionary, add this 5, add this 16, add this 8, this 4. I'd like to add all these different numbers to our dictionary. So first of all what we'll do is we'll just add this x and current chain, because this is going to be really easy to do, and then we'll look at how to add the other numbers as well. Be a little bit clever about it. So okay, so what we're going to do first is we're going to define our dictionary. So we're going to have dict of known collatz. That's going to be empty to start with. Now once we find our x and our current chain length, so once we find the length of a number, we're just going to add to our dictionary. So we're going to say dict of known collatz, and then we add by doing these square brackets, remember. So we're going to say the key is x, we're going to set that equal to the current chain. So if I do that and then I print out down here, if I print this dictionary at the end, we should see. So you see we get 1 1, 2 2, and then 3 8. Now if I go up to 10 here, so we get a couple more. You see we actually are starting to get a dictionary that includes all the corresponding values. Now that's great, we've now got a dictionary. Now what we need to do is use it. We need to look at how we're going to help improve our code using it. So what we want to do here in this while loop that's going to be collatz and stuff right here where I've just made a little space, we want to say if the current number is in our dictionary, then we could increase the current chain by the current number's corresponding value in the dictionary, if that makes sense. So let's try code that. So if current number in dictive non-collatz dot keys, so we're looking in the keys area to see if we have this number. So what I'm going to do is I'm just going to print found number, and then I'm going to print what that number was. So current number, and I'm also going to print the dictionary. Now if we just run this, you see, so it finds the number 2 because the dictionary has the number 2 in. It finds the number 2 again, the dictionary has the number 2 in. It finds the number 4 because it has the number 4 in. So since we're working now, when we find the number, what we want to do is we want to say, if you found it, the current chain is plus equals the dictive non-collatz, and then we need to look up a key. So the key we're going to look up is current number. Now I want to print this current chain before and after. Whoops. Current chain here. Print current chain there. I'm also going to drop this down to 3 just to. No, I'm not. I'm going to go to 4 because 4 is probably the first one that has a shortcut in. So what's 7 now? Oh, so it's printing out the current chain, right? Okay. So the longest chain was 10. The number that produced this was 3. So the longest chain was 8 here. The reason this is doing that is because once we've been in here, we want to say current number is equal to 1, just so it breaks out of this while loop. Just check that. That went wrong. So I'm just going to call a break here. So the longest chain was 9 now. Still getting 1 too many. Is that because of this line? So there's only these two lines I'm actually skipping out. If I back down a bit, plus back up. When I break here, there's only these 2 lines I'm skipping out, and I'm not sure why I'm getting an extra 1 added on this. What I'm going to do is I'm just going to comment out this a sec, and now I want to collatz up to 10. and I want to print out the X and the current chain. I want to see what all these different chains are, just so I have numbers to compare against. Now, if I get rid of that again, bring this back. I don't need all these prints in. I'm going to get rid of. Now, you're going to see all these numbers are slightly out. So 3 is slightly out. 3 goes to 9 now. 4 is slightly out. 4 goes to 4. So they're all out by 1. Then 5 is out by 2 because I think 5 ends up looking up one of these numbers that are out by 1. So this can be out by 2. So each time I'm looking up a number, I need to be taking away 1. I think. If I just minus 1 off here, is this going to work? Yeah. So you see, these are the right answers right here, and these all match them. So this is definitely working. Now, I'm gonna first of all, am I going to delete all these prints? So hopefully you understand what's going on here. When it finds a current number in the keys of our dictionary, so when the number we're at is in our keys of our dictionary, we know that the answer has already been found for that number, so we're going to look it up using this little piece of code right here, and we're going to say add that to our current chain, and then move on from that. That's our current chain at -1. I think the reason we're -1 here is because we're actually counting like 1 going to 1 as one step. I think that's where it all stems from, so 1 is actually the problem, but I'm not sure, I'm not certain on that. Either way, this works, don't worry about it. So if we now change this number to a million, is that a million? Yeah, it is. If we now change this number to a million and we run that, I'm curious to see if this is actually going to be faster. Whoops, didn't mean to do that. So you see that was actually way faster, 5.9 seconds. Where am I print dictionary? There we go. If I get rid of that print. So you can see the first way we did without this dictionary took like 69 seconds to run. Already we've got that down to 4.8 seconds just by implementing this. Now there is something else I want to add. I want to be able to add, like I say, on the 3 chain where 3 goes to 10, I want to be able to add that 10 to the dictionary. Currently that's not the case, it's not actually getting added to the dictionary. The only numbers getting added to the dictionary are the X values, so like it'd add 1, then it'd add 2, then it'd add 3, then 4. It's not adding like the middle of the chain values. So what we're going to do here is we need to keep a list of, so right here I'm going to define a list. So numbers in the chain, that's going to be equal to an empty list. Now numbers in the chain, what we're going to do with this, actually what I'm going to do here, I'm going to put this in a different file. This is going to be saved as 14.1, and now we're going to be working on 14.2. Because I'm not certain this one's going to actually be quicker. There's going to be a lot of stuff added to this dictionary, so we'll see. Okay, so in chain equal to empty list. Now what we want to do is, if we're collapsing the number right here, obviously our number's going to change, so just before we collapse the number, we want to do numbers in chain dot append, and then we want to append current number. Now I'm going to drop this number all the way back down to 10, and I want to print out numbers in the chain. Did I not save this? Oh no, I did. This is 14.2 now, .py. So you see we're getting all these different lists of numbers. If I just drop this to 4 sec, focus on just these. So gives us 2, 3, then 3 goes to 10, 10 goes to 5, 5 goes to 16, so it's working for these. Now when we get to 4, you see we're not actually putting 2 on the end of this list because it finds 4 in our, it finds 2 in our table, sorry, 2 would already be in our dictionary. If I just print our dict here, you see here's where it gets to 4 and then it doesn't show the 2 because the 2 is already in the dictionary. So when we actually step inside this dictionary to get our chain length of all the value we're at, we also need to get the chain length of all these different numbers in our list because we can add all those to our dictionary now. So what we're going to do is, if I just comment these out, probably not going to need these, I can delete these I think, but we'll see. Instead of saying the current chain plus equals the dict of known collatzed minus 1, we're going to say the current chain is going to equal that, but then we're going to also append, well not append, but also add a load of other things to our dictionary. So where did we actually add to our dictionary? We added down here. So instead of doing that, what I'm going to do is I'm going to put this up here. I'm going to say dict of known collatzed x equals current chain plus dict of known collatzed current number minus 1. Now, if I get rid of this, this should no longer be necessary. Does that work? Yes, that works. It works for numbers of 10. So that works, or it seems to work. So all I'm doing here is I'm changing where I'm adding these numbers to the dictionary. The current chain still needs to stay at this number, or does it? Yeah, it does, because we need to know when we're getting a new longer chain. So this line here needs to stay, the line 19 needs to stay. Now line 21 I moved. This is adding to our dictionary. Now we want to also add all the items in our list to the dictionary. So we're going to say for number, or not for number, we're just going to say for I in our numbers in chain. And we're just going to print I for now. Okay, why are we not save that? What is actually going wrong here? Why is it not? It's never actually entering here. But if current number is in because we're not actually Okay, so what we need to do is this line right here. So what was our line down there before? Like predictive known Collatz x plus equals current chain. But if we run this, are we going to step inside? Yeah, there we go. So the problem was, it wasn't actually, the dictionary wasn't getting filled, because the only reason it steps in here is if the number is actually inside the dictionary, and if the number wasn't in the dictionary, then it's not going to step in to add numbers to the dictionary. So I just made a mistake pulling this inside. I'm going to actually get rid of this, I think. Now, if we yeah, so the only reason we're gonna have numbers in this list that we need to go through and add. No, sorry, that's wrong. So this thing here, I need to actually move this to somewhere where it's going to get called no matter what. Because if there's stuff in there, I do want to be appending it to our list. So as it is, this should work. So we get the longest chain, 15 by 7. Chain was 63. So the reason this is going wrong is because obviously adding the this line here is wrong. So if we get rid of that, I'm going to copy this line. This is the line we're going to need, I think. Wow, this is harder than I thought it would be. Right, so 3 works. I think the rest work. I have to check this. So okay, so it's not working. Okay, what I'm gonna do, I'm gonna call this video here, since I'm now stuck. This video is like 28 minutes long. I will fix this problem right after I cut this video. I'll make a new video, and we'll go through how to add the numbers within the chain to the dictionary. So for now, what we've got is our point 1. That this one here works. So the x is getting added to our dictionary and getting used. We're looking up that dictionary properly. So for now, just that works. Look out for the next video. The next video will fix the problem we've just found. So yeah, that's it for this one. Like if you liked it, subscribe if you want to see more, and I'll see you in the next video where hopefully I fix that problem. Thanks for watching. I'll see you in the next one.